Math topic of this unit out of 4. We have the solubility curves, we have concentration where we're going to do molality and molality. Molarity and molality. I said the same thing twice, sorry. Typically you say big M and little m. And then finally we're going to leave off with freezing point depression and boiling point elevation. So we're going to get into a little bit of concentration first, and it just has to do with how much solute is in a certain amount of solvent. When we're looking at the concentration, you can have a little bit of solute or you can have a lot of solute in your solvent. So if I have these blue beads here, with my blue beads that I have in here, each one would represent a water molecule. And then let's say that I have these red beads, which are my solute. I don't know, it's red food coloring, just to throw something out there. So when I add these two together, I'm going to add my solute to my solvent, and I'm going to mix them together. When I add my solutes to my solvent and I mix them together, I can figure out if there is a lot of solute in the solvent or there's just a little bit of solute in the solvent mathematically, and that will tell me the concentration. So when we look at these, this one has my blue beads with my red beads inside. This one just has a few red beads scattered throughout. This is not very concentrated. We compare it to this one that has a lot more of the red beads in there. This is more concentrated. There are more solute particles here than in this one. So when we look at these, when you add your solutes to your solvent, you mix it together, you can have more solute, you can have less solute. And mathematically, we're going to calculate that value. To look at something that is concentrated in the real world, when I was growing up, my mom didn't let us go to the grocery store. That was just her thing. She got off work. She worked at a bakery, my family's bakery. And so when she got off of work, she would go to the grocery store before we even got home from school. So I wasn't allowed in a grocery store ever pretty much growing up. And so I didn't know until I was embarrassingly old, like college age, that orange juice came in a jug that you could just drink. We always bought the concentrated orange juice. Concentrated orange juice you find in the freezer section, and with that concentrated orange juice that you find in the freezer section, you add like 3 cans of water to it, you shake it up, and you magically have orange juice. I thought that's just how orange juice came. But that orange juice concentrate takes the water and it evaporates it away. So a lot of people when they're buying orange juice, they say, don't buy the stuff from concentrate. All that means is they took oranges, they evaporated some of the water away, they transported it, and then they reconstituted it. Or you buy that orange juice concentrate in the freezer section, and you can add your own water to it. So there's less packaging there. So with your orange juice, you can have more concentrated orange juice and less concentrated orange juice. And if you ever buy that orange juice concentrate and you just try it, it's really intense in flavor because it doesn't have the water there. So when we're looking at the concentration of a solution in chemistry, we can mathematically calculate it. We mathematically calculate it. It is called the molarity. Molarity, typically people say big M. There's also little m for molality. It's a different calculation that you're going to see in a separate video. But typically we're going to use molarity. In the labs throughout the year, if you've actually read the labs like I've told you to, it says like use 3 molar. It'll say like 3.0 big M HCl for hydrochloric acid. That just tells me the concentration that I need to mix together to get out for you guys. So do I need a really concentrated acid or a not so concentrated acid? With your molarity, it is, that looks really weird. Sorry, I don't know why that is not. Let me see if I can move that over. I don't know why that looks so funny. Oh, I went too far. It is how many moles of your solute get dissolved into however many liters of solvent. So remember I said that we had to figure out which is your solute and which is your solvent? This is why. One of your values you're going to have to turn into moles. Your other value you're going to have to turn into liters. You divide the two to get your molarity. So typically we have big M is equal to moles per liter. On these problems, you can use a triangle to solve for them, and I'll put the triangle on my paper when we actually solve the problems. But we have to remember how to get from grams to moles and how to get from milliliters to liters. But the unit that you use for your answer is actually moles per liter, but we usually just write that as a capital M. You have to be very careful when you're writing your capital M versus your lowercase m because you're going to see both of them in your calculations. Or if you prefer, you can just write out moles per liter. It's up to you how you want to do that. So with your molarity, it just tells you how many moles, how much of your solute is dissolved into however much of your solvent. It's moles per liter. The higher the number, the more concentrated it is. The smaller the number, the less concentrated that it is. So if you see a number less than 1, it's not very concentrated. If you start getting into numbers that are like 10, 12, 15 molar, those are pretty concentrated. You're never going to get huge numbers with these. Typically, your answers are going to be like 0.025 or 1 molar or 3 molar or 6 molar. Again, if you start getting numbers of like 12 and 15, that's a really big concentration for these. That means that you have a lot of moles in your solution. So with these math problems, again, I'm going to switch over to my document camera. And when I switch over to my document camera, I have the same problems here. It says a student dissolves 2.75 grams of sodium hydroxide in water to make 250 milliliters of solution. What is the molarity? Molarity is big M of the solution. So big M is equal to your moles of solute divided by liters of solvent. Now, if algebra is not your strong suit on these, you can use a triangle, I dragged my pen, to solve for them. With your triangles, you have your big M is equal to your moles of solute divided by liters of solvent. That'll help you to rearrange the problem if you need it. So when you're rearranging the problem, if you don't know your molarity, like on this one, you take moles divided by liters, because moles is on top of liters. If you don't know your liters, you cover that one up, and you're going to take your moles divided by your big M to get your answer there. When they're across from one another, you multiply, so you take your big M times your liters to get your answer. So when we're looking at these, it says a student dissolves 2.75 grams of sodium hydroxide into water to make 250 milliliters of solution. So this number right here is going to need to go to moles, because that's my solute. 250 milliliters is going to go to liters, because that's my solvent. Grams is always going to go to moles. Milliliters is always going to go to liters. You can't take milliliters and go to moles. So with this problem, I'm going to have to take my 2.75 grams of NaOH, sodium hydroxide, and convert it out into moles. To do that, we have 1 mole is equal to however many grams there are from the periodic table. So to get the molar mass of sodium hydroxide, I find the mass from the periodic table. Sodium is 22.99. Remember, molar masses always have 2 decimal places, so that's why I have 2 decimal places. Plus 16 for my oxygen, plus 1.01 for my hydrogen. That gives me 40 grams is the mass of 1 mole. So to get my moles, I take 2.75 divided by 40. I have 3 sig figs here, so I need 3 sig figs in my answer. 0.0688 moles. So I took my grams, turned it into moles. To take my milliliters and go to liters, we're going to divide by 1,000, or we move our decimal place 1, 2, 3 times, however you want to do that. It's up to you. Divide by 1,000 or move it 3 times that way. Before the move, I had 2 sig figs. So after the move, I'm going to have 2 sig figs. So my liters is 0.25 liters. So now I can just take my moles divided by my liters. 0.0688 divided by 0.25 will give me my molarity, big M. So 0.0688 divided by 0.25. When I get this answer on my calculator, I'm going to get sig figs. I've got 3 sig figs and 2 sig figs, so my answer can only have 2 sig figs. So you have 0.28 molar. So it's not very concentrated. I have another example here. For my other example, Again, I have my big M is equal to my moles divided by my liters. If you like the triangle, I'll write that down here. It says you need 1.75 liters of a 3 molar sodium hydroxide solution. How many grams of sodium hydroxide do you need? So on this one, I have my liters, I have the big M. When I have liters and I have big M, the only thing that I can solve for is moles. Now the question's asking for grams. Once I have moles, I can take that to grams by using a conversion factor. The conversion factor that I need is 1 mole is equal to however many grams there are from the periodic table. So my first step, use these two to get the moles. Then I can get grams from there. So according to my triangle, I don't know moles, so I'm going to cover that one up. When I cover that one up, I'm going to take my 3 times 1.75. That's going to give me moles. This has 1 sig fig, 3 sig fig, so I'm going to have 1 sig fig in my answer. So 3 times 1.75 gives me 5 moles. Now I can take my 5 moles of sodium hydroxide and convert it out to grams by finding the molar mass on the periodic table. Now luckily, sodium hydroxide, that NaOH, is the same thing that I just had in the last problem, that we found the molar mass already. But when I found the molar mass, I took sodium plus oxygen plus hydrogen's masses from the periodic table. Just as a reminder, those masses are at the bottom of each of the different squares. So phosphorus is 30.97, silicon is 28.09, aluminum is 26.98, things like that. So 1 mole of NaOH has a mass of 40 grams. So now I'm going to take 5 times 40 to get my answer. I don't need a calculator for this one, but just to show you what I'm doing. I'm taking 5 times 40 divided by 1, which I don't need to do. That gives me an answer of 200. That has 1 sig fig already, so I'm just going to write down 200 grams of NaOH, and that's my final answer. So if you guys have questions, ask. Otherwise, the equation is the most helpful thing here. If something ever asks you for grams, solve for moles and then go to grams, but typically that's the most difficult part about these. If you guys have questions, again, my email is mgable@crosbyisd.org. Have a good day.